Okay, it's back for the second calculation. We're going to do the same two parts of the demand line, except we're going to be going the other way. We're going to start at $6 and we're going to go down this way to the right, and so we're moving this way. So the change is still going to be $2 down and 600 quantity over, 600 pounds over, but it will give us a different number. And so again, we want to have the change in the quantity over the first quantity. Well, the change in the quantity is still 600. But now, since I changed the quantity to 400 now, because I made a mistake, and that's what the graph says. So at $6, the starting quantity is 400, because we're starting at this point, and that's a starting quantity, starting price. And then we want to divide by the change in the price right there. Change in price is still $2, and then the first price now is 6. So I got these zeros I can just cross off, and then 6 over 4, just leave it at 6 over 4. Here I times top and bottom by, 6 over 2. So it's gone there, and now I have 6 over 4 times 6 over 2. Right there. And I could have changed that to 1 over 3, couldn't I? Well, I'll do that now. So it's 3 over 1, and that's 18 over 4, right? And so that would be 9 over 2, right? And that would be 4.5, right? So we have two different numbers. If we start at $6, we get 4.5, which is a lot higher number than if we start at $4. So starting at $4 makes it look a lot less elastic than starting at $6. The reason why is here. If you start at $4, you're going to start at a higher quantity, and so the 600 change is going to be a lower percent because you have a higher quantity, while the price change is going to be higher percent because you're going from 4 to 6, and so that would be a much higher increase. That would be a 50% increase in price. If you do the second calculation, going from 6 down to 4, well, now your quantity is going to look higher because you're going from 4 to 1,000, you more than doubled. And then your price change is going to be smaller. Now it's going to be a 33% change, decrease in price, as opposed to 50. So by starting at 6, we make the price change look smaller, we make the quantity change look higher, and so you get a much higher number. And that's a problem. Your boss wants to know the elasticity between $6 and $4, and you have two different answers based on where you start, and that creates a problem, both for economists and for your job, because your boss is going to say, I don't want one number. I'm sorry, I don't want two numbers, I want one number. So economists have fixed this problem. Instead of deciding on where we're going to start from, don't worry about it, just take the average. And so again, we have price $6. And $6, the quantity demanded is 400. And then at price $4, the quantity demanded is 1,000. So up here, we still take the change. It should be the change in quantity. So take the change in the quantity demanded, which again is going to be 600, the difference. So we have 600 right there. And then we want to divide by the average quantity. Again, don't worry about where you start from, just the average. So the average is right here, and that would be right smack in the middle. And so 700 would be right smack in the middle. If you can't see them, add them up, divide by 2. So 1,400 is 1,400, divided by 2 is 700. That's the average of the two quantities. Change in the price is still 2, and the average of 6 and 4 is right smack in the middle, 5. Knock off those zeros, and then I can times the top and the bottom by 5 over 2, and that's why it's gone in the bottom. So now we have 6 over 7 times by 5 over 2, that'll be 30 over 14, right? And so that'll be 2, we'll take away 28, because twice 14 is 28, so that'll be 2, and then we have 2 14s left, which is 1/7, right? That'll be 2 and 1/7. So instead of saying it was, what were the two numbers we had? Instead of saying it was 1 1/5 or 4 1/2, 4 halves, it's now just one number, 2 and 1/7. And that's the midpoint formula. So on the exam, if I gave you two prices and two quantities, you're going to estimate the price elasticity of demand using the midpoint formula, which is the change in the quantity demanded over the average quantity demanded over the change in price over the average price. And so we have two formulas right now. We have the midpoint formula, and this is used to estimate the definition, which is the percent change in the quantity demanded over the percent change in price. So this here is used to estimate that if we have price quantity data like up here. Let's apply that here. Let's say we have a demand line. Looks like that. So at price 120, the quantity demanded is 0, and then every time the price goes down by $10, we buy 10 more. And so let's find the elasticity of demand between, say, 120 and $100. So again, we want to use the midpoint formula, which is the change in the quantity demanded. And so the change there is going to be 10 divided by the average quantity. Average quantity. And the average of 0 and 10, add them up, divide by 2 is 5. And divide that by the change in the price, which is 20, over the average price, which would be 100 and 120 added together, and divide by 2, right smack in the middle, would be 110. And so 10 over 5 is 2. And then we can times by the reciprocal of that, 110 over 20, and that comes up to 11. And that's what I did down here. So that would be the change in the quantity, average of the two quantities. Change in the price is 20, average is 110, that's 2 over 1, and then I can times by 11 over 2, reciprocal, and that gives me 11. If I go here, the change is going to be the same, but now the average is going to be 15 higher. Change is going to be 20, but the average is going to be 90 now. By doing that, I'm going to make the denominator, it's going to be a smaller number, larger number, and the numerator is going to be a smaller number. I'm dividing 10 by a larger number each time, so the change in the quantity demanded of the average is going to be shrinking, while the change in the price is going to be rising, and that's going to be causing these numbers to go down. Jump down here, we have 20 over 10 and 50 to 60, so that would be a change of 10. Average is 55. Change is 20, the average is 10. It makes this number really small, that one much larger, and the number is really small, 0.09. So what this means is that when you go down a straight line demand line and you change the price, drop the price, elasticity of demand is going to be falling. So elasticity is not the slope. The slope is constant. Every time we drop the price by $20, we sell 10 more. That would be 20 over 10, a slope of 2. So the slope is going to be 2 all the way down. But slope is not elasticity. Elasticity is not slope. And so elasticity is going to be changing. And so right here, note there's going to be 3 regions for the elasticity. Any straight line demand line. The upper part is going to be elastic. The lower part is going to be inelastic. And right smack in the middle is always going to be unitary elastic. So up here it's going to be greater than 1. Down here is going to be less than 1. And the further you go. So it's going to be a little bit inelastic there, a lot more down there. A little bit elastic there, a tiny bit elastic, a lot elastic there. So here, as I go down, it's going to be becoming more inelastic. Or if you're going up the other way, it always becomes more elastic. And that's always the case. And I'll stop there.